For innumerable generations, humans have surveyed the vast expanse of the night sky, driven by wonder about the numerous unanswered mysteries of the universe. In the 20th century, researchers introduced the Big Bang model that sought to clarify the source, progression, and expansion of the cosmos. Yet, even with its broad endorsement, this theory still falls short in addressing some of the deepest questions surrounding the universe. In recent years, groundbreaking findings have added even more layers of complexity to these cosmic puzzles. For instance, in 2023, NASA's James Webb Space Telescope made an amazing discovery. It discovered celestial objects that seem to be older than the universe itself. This astonishing observation has left scientists initiated and confused, sparking discussions about whether stars could truly exist for a duration exceeding the currently accepted age of the universe. Such a paradox challenges our existing scientific frameworks. Could this inconsistency suggest the necessity for an entirely different cosmological model? These and numerous other questions will be discussed in this video. To remain kept abreast of the most recent astronomical breakthroughs, make sure to subscribe, like the video, and enable the notification bell. Roughly 200 light-years away from our planet, within the Asin-Lee constellation, a star designated HD 114283 exists. What sets this star apart is its exceptional speed, traveling at 44.83 km/s, which offers critical clues about its chaotic past. Approximately 1 billion years ago, when the Milky Way was in its formative stages, it collided with a smaller satellite galaxy where this particular star was born. However, the most remarkable trait of HD 114283 is not its velocity but its age. This star is among the most ancient stellar bodies ever recorded, earning the moniker Methuselah, a nod to the biblical figure thought to have lived 969 years. Early age estimates placed it at a phenomenal 16 billion years old, but more refined. Calculations have brought this down to 14.46 billion years, with an uncertainty range of about 800 million years. This variance presents a serious conundrum when contrasted with the current estimate of the universe's age, about 13.8 billion years, based on measurements of the cosmic microwave background radiation. This leads to a significant inquiry. What exactly is this immense stellar body? How could a star be older than the universe itself? Such a concept defies our present scientific knowledge. As a direct result, scientists have begun re-evaluating the precision of our tools and methods for determining the ages of both stars and the universe itself, prompting deeper research into these cosmic mysteries. To grasp the magnitude of this issue, it's important to understand the difficulties in estimating stars' ages. Stars, such as our Sun, retain relatively steady temperatures and dimensions over billions of years, which makes pinpointing their age with accuracy especially difficult. Astronomers examine slight shifts in a star's brightness and color and compare these findings to theoretical life cycle models of stars. One critical metric for calculating a star's age is its spin rate. Just as a rotating wheel slows over time due to resistance, stars gradually reduce their speed of rotation. By measuring the spin of stars at different ages, scientists have formulated mathematical techniques to approximate a star's age using a process called gyrochronology. Methuselah, the star in question, is, in fact, the oldest known star in existence. Measurements taken at the present time suggest it is the oldest known star in existence. Rather than dwelling on whether it could be over 2 billion years older than the surrounding universe, we might instead ask, is it possible that the universe is older than previously believed? Encompassing 13.8 billion years of time is not straightforward. If the universe's timeline were condensed into a single year, with the Big Bang occurring on January 1st, Earth would not appear until the final moments of December 31st, and human civilization would exist for only a few fleeting seconds. Scientists determine the age of the universe by analyzing light emitted by distant stars that emerged hundreds of millions of years following the Big Bang. As the cosmos continues to expand, this produces a phenomenon known as redshift. By studying both how far away objects are and how quickly they are receding, researchers have concluded that the universe is roughly 13.8 billion years old. Nevertheless, recent research from the University of Ottawa suggests a much older universe, possibly around 26.7 billion years. Dr. Reinder Gupta, a physicist at the university, proposed a theory that integrates Swiss astronomer Fritz Zwicky's 1929 idea with contemporary developments in physics. His hypothesis posits that protons lose energy over long spans of distance and time, opposing the traditional understanding of redshift. Gupta suggests that redshift could be reinterpreted as a combined effect, not solely caused by the universe's expansion. This revised interpretation could lead to a significantly older age estimate for the universe and might offer solutions to enduring cosmic mysteries, especially those highlighted by NASA's new observations. Gupta's framework builds on the hypothesis of tired light and the concept of changing interaction constants, first introduced by theoretical physicist Paul Dirac. This idea proposes that certain fundamental interactions in the cosmos may have evolved over time. It is crucial to acknowledge that our perception of the universe's age has changed significantly. In the 1920s, Edwin Hubble theorized that the universe was only approximately 2 billion years old. Subsequent discoveries, however, greatly increased that number, eventually settling on the modern consensus of 13.8 billion years. Whether we interpret human history as lasting only 10 seconds or 5 seconds in the grand cosmic timeline, one fact remains certain. The universe is incredibly ancient. Its ongoing expansion continues to test our assumptions about its age. Meanwhile, new revelations regarding our own Milky Way galaxy are raising fresh questions. Data now suggests that stars located on the galaxy's outskirts move significantly slower than in other locations. A few possible theories have emerged. One is that our galaxy may have an unusually low quantity of dark matter, an unseen form of matter thought to account for the vast majority of gravitational pull in space. On the other hand, our understanding of dark matter and how it is spread throughout the universe may have fundamental flaws. This uncertainty arises from information gathered by the European Space Agency's Gaia mission, which has charted the locations of nearly 2 billion stars within the Milky Way. These results have led scientists to revisit their models of how stars behave, especially in the galaxy's outer zones. The speed of a star's orbit is a crucial aspect in calculating the total mass of a galaxy, as gravitational pull is directly related to mass. A recent analysis, based on estimates made by Gaia, suggests the Milky Way's mass, including stars and gases. Additionally, there are approximately 200 trillion times the mass of the Sun, which is 5 times lower than earlier projections. This decrease might reflect a reduction in observable material within the galaxy, possibly pointing to a lower amount of dark matter. But determining a galaxy's mass is incredibly complicated, and there may be inconsistencies in either the satellite data or the analysis methods used. As new insights are uncovered, we will continue to follow these revelations closely. In the years ahead, technological advancements and new space missions are expected to provide deeper comprehension of these problems facing the universe. With its exceptional abilities, the James Webb Space Telescope will continue to push the boundaries of what we know about the universe. We're not only investigating the age of stars or the universe, but also trying to comprehend the intricate mechanics of galaxies' dark matter and the forces that govern cosmic evolution. Understanding the expansion of the universe is still a core area of research in astronomy, but as we collect more information, we may realize that our previous conclusions were constrained or even flawed. One major question is whether we have come to believe that physical laws apply uniformly throughout time and space, Could unknown forces or yet undiscovered phenomena be influencing how galaxies move or how stars age? As our tools become more sophisticated, we may uncover new elements of the universe that defy even our most accepted theories. More and more researchers are recognizing that our comprehension of dark energy, dark matter, and fundamental forces may be incomplete. Every brand new observation made faraway galaxies to ancient stellar remnants brings new insights, but also introduces new uncertainties, pushing the limits of our scientific understanding. The notion that stars could predate the universe or that the universe might be older than current models urges a total rethink of our approach to cosmology. This might call for novel physics, new theoretical frameworks, or even radical ways of looking at time and space. Additionally, developments cause deep philosophical reflections about existence itself and humanity's place in this vast cosmos. If confirmed, such findings wouldn't just redefine science, they could revolutionize how we view reality as a whole, including discussions about real age of the universe persist. One thing is evident. We stand at the edge of a time in astronomy that was pivotal. Next few decades might provide answers to questions that have challenged us for thousands of years, whether we're exploring ancient stars or probing the unknown forces of dark matter and dark energy. The cosmos remains full of secrets waiting to be uncovered. The journey ahead is one of discovery, exploration, and constant reassessment of what we believe we know. Whereas the responses may still lie beyond our grasp, the excitement of exploration is just beginning. For more updates on these fascinating studies and theories, stay curious and stay connected. You never know what incredible frontiers of knowledge we'll reach next. If you'd like to stay informed about the latest in space science and astronomy, subscribe to our channel, hit the like button, and turn to ensure that you never miss a thing. As we venture further into the mysteries of the universe, the future is rich with potential. The James Webb Space Telescope, with its revolutionary imaging technology, is poised to be a pivotal instrument in unraveling cosmic secrets. Already, it has unveiled astonishing new insights into remote galaxies, alien worlds, and other celestial phenomena, but as Webb, its mission has just begun. Probes deeper into space. It could reveal information that transforms our basic comprehension of the workings of the universe. Among the most thrilling areas of research is the hunt for life-supporting planets. With new exoplanets identified in what is known as the habitable zone, prospects of discovering extraterrestrial life have never been brighter. Although current findings don't offer definitive proof of life beyond Earth, they certainly suggest the possibility. Discovering even microscopic life elsewhere in the cosmos would have sweeping implications for science and philosophy, altering our beliefs about evolution biology and humanity's role in the universe. Additionally, as we continue to investigate the enigmatic forces of dark matter and dark energy, our scientific frameworks will face further scrutiny. These mysterious components, which make up most of the universe's total mass and energy, remain largely misunderstood. How to solve the puzzles surrounding dark matter and dark energy could unlock profound insights into the very essence of the universe. Alongside this, another vital focus is the study of galaxy behavior and movement. For example, the realization that stars in the outer. The Milky Way is moving more slowly in some areas than anticipated has led scientists to revisit models of how galaxies function. This may indicate that our galaxy, and perhaps others, possess significantly less dark matter than once assumed, raising important questions about gravity and cosmic structure. Such revelations highlight how fresh data can compel us to overhaul even our most foundational theories. In the same vein, evidence for the evolution of galaxies in previously unrecognized ways shows the importance of refining our cosmological models. Could the universe be vastly? Are there chapters that are older than we think, of its history still hidden from view? These are the types of puzzles researchers will strive to solve in the years to come, as they gather observations from new and existing space. Exploration efforts. One thing is clear: our current picture of the universe is incomplete. The more we discover, the more we realize how much remains unknown. This sense of awe and the endless search for knowledge are what fuel the spirit of scientific inquiry and exploration.